Those 50 minutes will be filled by Mario Lasnig, who will be talking about an interesting, at least to me, very interesting confluence of things that we've heard about before in this conference. SWAN, Jupyter as data munching entities on top of the EFSS ecosystem, and meshing it with Rucio, a data orchestration tool in use by SWAN and several other organizations. Is that enough of an intro, Mario?
You just did half of my talk there. Oh, cheers.
Take it away.
I do. Okay, I click on share screen and hopefully I got the right one.
Perfect.
Is that all right? Okay, great. So I wish I could compete with the Order of Australia. I don't think anybody of us has that. And even in my case, the Order of Austria was disbanded. Well, at least I got tenure at CERN, so at least I'm going to stick around. So that's that. So what I'm presenting here is the work of very many people. So of course, all the praise must go to them, and for all the mistakes, the blame must go to me. And especially I want to highlight Muhammad out of the author list, who was the one who did the work. Okay, let's go to slide 2, if I push the right thing. Okay, so what was the idea? The idea is as simple as ages old. We want to help scientists work productively with lots of data. And the kids these days, they don't tend to work with command line interfaces very well anymore. So we have these Jupyter notebooks coming up, and people want to do their physics analysis in these notebooks. But they don't really tie very well together with the exascale data we're starting to have. How can you access and search your data sets? How can you avoid to switch between all the different services that you might need to actually do your analysis, and then integrate it with these notebooks? And when you're done, how do you share all of this? So the idea came up since these Jupyter notebooks started to become very prominent. Maybe data started just last year in Copenhagen at the CS3. We flashed 2-3 slides on this, and we received very positive feedback. And 2 natural candidates in this presented themselves, and that was, of course, SWAN and Rucio. So just one slide on SWAN. This is the Jupyter Notebook service at CERN. So you can do your analysis in the web browser. You don't need a local installation. So everything basically runs in the cloud. I think people are aware of the concept. The really nice thing about it is that it supports multiple ecosystems. So you can run your analysis with Python, with Root in C++, and also have R and Octave available. And then share this with your other scientists, plots the data and the code with your other colleagues here. All of this works in the background through CERNbox and thus EOS. The software is procured through the CVMFS. And of course, we get with Spark batch processing capability, which is very nice as well if you want to run a little bit bigger analysis. And on the other hand, Rucio, which is our data management federation, as you can see by the number of logos there, used by quite a lot of communities now, which provides an integration of your scientific and commercial storage and the network systems. The really nice part about Rucio is that it provides the single global namespace across heterogeneous resources, and they can be distributed all over the place. This originally came from the Atlas experiment, but now we really have widespread usage of it. And it's also one of the highlights that it was free and open source, built from the ground up, so everybody can contribute, and people are doing that. Okay, so to get a sense of scale, what the scientists have to work with, just grab the numbers from Atlas. So we have something like 1 billion files, half an exabyte of data, quite a high interaction rate, 120 data centers, including HPCs. We have commercial clouds. And then there's quite a lot of data being moved between those data centers, and multiple exabytes of data. And that is the important number, because that is basically uploaded and downloaded to the worker areas where the jobs are being run. And when we have Halloumi LHC coming up in a couple of years, you can basically put a 0 after each of these numbers. Well, unfortunately, not the number of data centers, but at least the bytes. Okay. So coming from the idea, we said, okay, how can we actually do this? And the idea was to do this together with Google through the Google Summer of Code program. So together with the Horizon 2020 project Escape, we said, okay, let's write a couple of lines, what we think how this could look like. And we had a very promising student apply to this project. We eventually selected Muhammad. And the idea was to build a Jupyter Lab extension. So this should be a generic extension. So it's just not only compatible with SWAN, but with any Jupyter Lab. And it should allow a couple of configurations to make it easier. And what I found really nice is that at the beginning of the project, Muhammad drew a couple of memes. The one in the bottom is very nice. This was his impression of what it looks like inside the LHC, where you have a couple of protons colliding and producing. I really enjoy that. Okay, so now let's have a look at the plugin. You should see the GIF moving, hopefully. So the idea was that within this notebook, you have kind of a sidebar where you can explore and browse the Rucio namespace. And then you can search for your data set, search for the files. And once you have them available, you can inject them in a notebook. And they instantly become available as variables. And this is pretty cool because this then means that you can actually, once you've associated these variables with the data sets, you can use them in your kernel. So here you have a test file attached, you can instantly read it. Now, when you share your notebooks, all of this becomes available to everybody else as well, because the attached data identifiers are the same within your community. So everything is resolved automatically, and that's pretty cool. The way this works is that it also integrates the authentication support that we have in Rucio. In this case, it's configured for X509 user certificates, and thus you get access to all the storage in the background. So now this means you could add a variable that points to potentially a petabyte of data, and in the background, the extension will sort that out for you automatically. Okay, so an overview of the architecture. On the left-hand side is the plot as we had it originally in the proposal. So you have the Jupyter Lab extension. It communicates with the kernel. It calls Rucio through its REST interface, and then goes with protocol-specific calls to the storage. And on the right-hand side, it's the actual implementation, which fortunately actually looks kind of similar. So you have the dataset browser and the authentication interface, which have their server extensions being called to the respective services, and the kernel extension that builds the data frames and connects to the Spark clusters if necessary. There's two modes of operation that you can use, either in a replica mode. So you have a network attached storage in between SWAN and Rucio. So you can transparently use the file transfer capability that Rucio has to make it available in your notebooks. Or alternatively, if the files you're working with are not so big, a couple of megabytes or so, you can also download them directly in your working directory. And all of this is handled transparently. Now, if you're a bit farther away, like in the case of Muhammad, that was in Indonesia, so we thought, okay, since we have a little bit of time left in the GSOC project, we can maybe add caching infrastructure. So in this approach, it's practically the same that we use in the Atlas experiment as well. And it's handled transparently. So all you have to do is deploy cache somewhere and configure the Rucio instance that you're already using to be aware of the cache. And automatically, the extension can then access the data through the cache, and you are hopefully saving on networking. Now, we did a couple of evaluations. Most of this was done through the Horizon 2020 project Escape, which is a really big project. So there's 9 experiments there. There's quite a lot of storage available. something that serendipitously appeared became very useful for this project. Now, of course, there's a couple of things that we need to figure out in the future, like the more authentication methods and improve a bit the latency hiding. But this is all in the development plan for the future now. There was also a test from Atlas where we managed to take the open data results we have, and that little bump that you see there in the plot, that's a little Higgs. So, and this was all done through the Jupyter Lab extension as well. It was also really nice. And already at my last slide, the next steps, we will now deploy this in production at CERN. We already the communities, not only to we need compatibility with more kernels. Python seems the hype to be these days for analysis, but C++ compatibility because it's the current de facto analysis language. We will add some more authentication methods because they're practically already supported by Rucio and SWAN. We need to pipe through, and then we see how we can share these notebooks across multiple Jupyter Lab installations and maybe automatically configure them with the existing Rucio instances. So I guess the main takeaway point here is that you can go from a crazy idea plugin in less than a year, thanks to very dedicated people. And I, again, would of course put very special thanks here to our Google Summer of Code student, Muhammad.
We have about 2 minutes for questions. I have one.
Yep.
Straight into production is what you said.
Since I did not write that sentence, I guess it's better for Ricardo to say what he meant.
But beautiful. Chat whether
there is a committed individual to actually sit down for an afternoon to copy the template that we have from the Python kernel and do the same for R. I don't see any particular problem with that because the interfaces to SWAN and Rucio are based on HTTP essentially. So you can call HTTP. You just take one dedicated individual.
all right.
developed. So I think if Ron is around here, he is one of the guys that is our connection to LOFAR and also to this work package. So maybe worthwhile to get together and discuss it on GatherTown one of these days of the conference.
We should put this on the agenda for the Science Mesh workshop later this week.